Hello everybody, happy Labor Day, and I hope you have enjoyed the day as much as I have. I am a little ragged. I just got back from the beach, but I decided I am going to get your 4.2 on for you. Remember, 4.2 was all about slopes of a line and slope-intercept form of a line. So just by way of review, remember we've gone over this in class. This little video is to help you with some problems. It's not necessarily to take the place of the PowerPoint that I have online, nor attending class. It's not supposed to be in place of that. It's to help you through just the actual execution of problems after you've seen all of that other stuff. So this is our slope formula. Y2 minus Y1 over X2 minus X1. Remember that Y2 and Y1 and X2 and X1 stand for the Y and the X values, coordinates of a point, a specific point. So we'll be given some specific points. The key point is that we subtract in the same direction. It doesn't really matter which point is point 1 and which point is point 2, as long as we stick with it once we've decided it, and we make this x2 correspond to this y2. In other words, they are from the same point, and the x1 and the y1 are from the same point as well. And we also have heard that the slope is the rise over the run, or the vertical motion over the horizontal motion. And this is the slope-intercept form of the line, which we are also studying in this section, where M is the slope and B is the y-intercept of the line. So remember, the B is where it crosses, the line crosses the y-axis. Also in this section there are just some things we ought to know about slope. A positive slope is going to climb from left to right, and a negative slope will decline from left to right. Okay, so we read a slope just the same way we would read a book, left to right. So if it is climbing, it is positive. If it is declining, it is negative. If it is a flat slope, in other words, that one doesn't quite look flat, does it? Let me see if I can do a better job of a zero slope. Not going up, not going down. It is just flat. That is a zero slope. And an undefined slope is a vertical line. Vertical lines have undefined slope. So then, this reiterates that vertical lines have undefined slope and horizontal lines have a zero slope. And we're going to start determining the slope of a line between 2 points, both visually and with the formula. So I have graphed these 2 points for you, -2, -5, and 4, -3. Now if we're going to do this one with the slope formula, we would take the difference between the two y values. So if I did -5 minus a -3 on the top, -5 minus a -3 on the top, then since I started with -5 in the y values, I would have to start with -2 on the x values, -2 minus a 4. Okay, so remember, when we minus a minus, that's going to become a plus. So -5 plus 3 is a -2. And so a -2 over a -6, and a negative over a negative is a positive 1/3. Okay, so calculated with our little formula, the slope is 1/3. Hopefully, when we do it visually, we will also get the slope of 1/3. So let's look at the graph. And if you look at the graph, this is the distance between points right here. This is a step up of 2, but then horizontally, the 2 points, I have to move 2 places to get to 0, and then I have to move 4 more places to get to the 4. So they are 6 steps apart horizontally, And they are 2 steps. You have to take 2 steps up to go 6 steps to the right. So 2 over 6 is 1/3. So remember, we're always doing the rise and then the run on the bottom. All right, so now we have 2 more points, -2, 2, and -3, 6. So I drew -2, 2 is right here, -2, 2. Okay, so it's this point right here. And -3, 6 is right here. So if I were thinking about these as blocks that I was going to have to go, in other words, I can't go straight through a city block. I have to go down, and then I have to take, down 1, right 3, whatever. But I would have to, if I was going to try to find a straight line distance from this point, I would go 1, 2, 3, 4, 1. Okay, so I would go down 4, right 1 to get from one point to the other. So down 4, right 1 would be a slope of -4. So let's look at the points with the slope formula. M is y2 take away y1, so 6 minus 2. And this one goes with the 6, so -3 take away a -2. Well, we know a negative. -3 minus a -2 is going to be -3 plus 2, which is a -1. And this one on the top is a +4. So a +4 divided by a -1 is going to give us a -4 slope. So we get -4 whether we do it just visually, counting how many steps down before we have to detour and go over, or do it with our slope formula, y2 minus y1 over x2 minus x1. So here we have another one down here at the bottom, okay, and we're trying to find the slope between these 2 points. And when I look at them, look at my 2 y's are the same. So 7 and 7, 7 take away 7 is going to be 0. Now, it doesn't matter what the denominator is, does it? I've got 3 minus a -9, so that's going to be a 12. But 0 over 12 is just 0. So this is a flat line, a horizontal line, and it has a slope of 0, which we already talked about. All right, this last problem down here before we switch to a new slide is going to be difference in the y's. 3 take away a -1. 3 take away a -1 over 2 take away 5. All right, so now I've got 3 plus 1 is 4 over 2 minus 5 is -3. So remember, we talked about we don't leave the negative on the bottom. That would be a -4/3 slope. A -4/3 slope would mean it's a declining slope. So I'll be back in a minute with some more of our slides and problem. All right, so here we have 2 points, and we're going to talk about their slope. Well, notice that the points have the same x-intercept. So basically, when I subtract these, I get 3 take away a -1 over 4 take away 4. Oops. Now I have a 0 in the denominator. Since I have a 0 in the denominator, and I wind up with a 4 on the top, whatever I have on the top really doesn't matter because I have an undefined statement, undefined number here, so we have an undefined slope. So undefined slope. And we talked about undefined slopes were vertical lines. And if you plotted those 2 points, you would see that they are definitely one right above the other. Okay, so now we have 2 points, and we're going to subtract their x values y values, y values are first. On top, y minus a negative 5 over 2 minus a negative 5, difference in my y's, over the same point I started with before, negative 7 minus a negative 2. Okay, so now I'm going to 2 minus a negative 5 is a 7, and negative 7 minus a negative 2 is negative 7 plus 2, so that's a negative 5. So that slope is a negative 7/5. We would not normally leave the negative on the bottom. This one, it says graph a line containing negative 1, 4 with a slope of negative 2. Okay, so when I'm graphing something like this, I want to start with my point, and then from that point I will make the proper slope from there. So negative 1, 4 is one step over, and we'll have to make this tiny just because my board will say one step over, 1, 2, 3, 4. So that is negative 1, 4 right there. And then our slope of a negative 2 is the same thing as a negative 2 over 1, which means I'm going to go down 2, right 1, down 2, right 1. Okay, so I'm going to go down 2, right 1. Okay, down 2, right 1. And I will graph my line. And that is my line that goes through the point negative 1, 4 and drops 2 and goes right 1. So that's a slope of negative 2. Okay, so then we have graphed the line through to 0 with a slope of 4/3. So this slope is positive. Notice that this slope was negative, and it is declining from left to right. This slope should be positive because we have a positive 4/3, and we're going through the point 2, 0. So let me make a little grid on here. So 2, 0 should be right over here on the right. 2 steps to the right, 0 steps up. And then from there, I'm going to go up 4, right 3. Okay, so we would go 1, 2, 3, 4, right 1, 2, 3. Okay, so it's way over here. Oh, there's a point. Or, since I am running out of room, I can go down 4, back 3. Since your slope is positive, you can move down and left, and that would be a negative over a negative, which would give you a positive. So we could go down 4, 1, 2, 3, 4, back 3. 1, 2, oh, there's 1. I'm making them too small there. 1, 2, 3. Okay, I need to get consistent. 1, 2, 3. Okay, so we're going to draw a line through those points going all the way up through there. In a perfect world with graph paper, they would all be on the same line. Okay, so now we have a point, a line that is already in slope-intercept form. Remember, we said slope-intercept form is y is mx plus b. All right, so this equation that we're looking at has solved for y. Y is whatever is with the x, and it is a negative 2 that is with the x, is going to be your slope. And this 6 over here is our little b, which is our y-intercept. So to graph that, we will start with our point, which is our y-intercept. So it crosses at 6, so we'll go 1, 2, 3, 4, 5, 6. Okay, and we'll make a little point there. That's our y-intercept. And then our slope is negative 2, so we're going to go down to right 1 because we're trying to make it a negative slope. If it's down, it's going negative. So we would go over 1, negative 2 over 1. It's going to be down to right 1. So down to right 1. down 2, right 1, and I get my line. And it is a negative slope. Okay? And if I had a negative slope, negative 2 slope, I could also go up 2, back 1. It's the same thing as going down 2, right 1. Okay? Look at this one. This one down on the bottom is also in slope-intercept form. It has no b over here, which means that b is 0. Okay, because I put a plus 0 over there, then you can see that it is in this form of the line. Y is mx plus b. Okay, so our y-intercept is 0, which means that our line is going to exactly cross at 0, 0, right there at the origin. And we have a slope of 1 over 4, 1/4, which means up 1 over 4. So from 0, 0, we go up 1, 1, 2, 3, 4 steps over, and we draw our line. It's a flatter line. It's not flat, but it has a slope of 1/4. It is definitely a little bit flatter than something like 4. A slope of 4 would be sharp. Okay, so then we're going to talk about graphing lines using our slope and y-intercept, and we're going to start with a y is 2x plus 5. Okay, y is 2x plus 5, which is already in slope-intercept form. So our y-intercept is 5, our slope is 2 over 1. So we make our little grid. Doesn't look very nice and neat, does it? Make our little grid, and we're going to go up to a y-intercept of 5. 1, 2, 3, 4, 5. And our slope is 2. Okay, but we're up at the top of our graph. So our slope is 2 over 1. I could go up 2 over 1, but I am running out of room. But since it's a positive slope, I can go down and back and stay on my grid a little better. So down 2, back 1, down 2, back 1 is going to do the same thing as up 2, right 1. So we have our slope of 2, and there is our line. All right, we just have a few more problems to do before we're going to close this video up. All right, here we have a point, 5, 2, and we're told to graph this line with an undefined slope. Okay, so here's my little grid, and 5, 2 is going to be 5 steps to the right and 2 steps up. So there's 5, 2. And an undefined slope means it's a vertical line. So we would take and go straight through the vertical line, and that would be the graph. This one down here says go through the point 6, 3 with a 0 slope. So again, I'm going to plot my point. 1, 2, 3, 4, 5, 6 steps to the right and 3 steps up. So there's my point and a 0 slope. So my line is going to be flat, and there is a line of 0 slope going through the point 6, 3. Easy, easy. All right. Lastly, now we've been doing graphing with using our slope and our y-intercept, but notice that these two equations are not in slope-intercept form. This is an equation that is in standard form. Standard form has the x and the y on the same side. Okay, here we have 5x plus 2y equals 6. I'm going to do these for you 2 different ways. The first way is to get it into slope-intercept form. So the first thing I want is to get a y by itself on the left. So I'm going to take away a 2x. And over here on the right, I'm going to take away a 2x. Remember, whatever I do to one side of the equation, I must do to the other side. So now when I do that, my 2x minus my 2x disappears, and I get a negative y equals a negative 2x. But I don't want a negative y, I want a y. So I'm going to multiply both sides by a negative 1. And when I do, that's going to change the signs on both sides. So I get a y is 2x, and y is 2x has, so we have positive and positive. Y is 2x. That is in slope-intercept form, but we have no y-intercept. Okay, so we have a 0 y-intercept. So we're going to make a 0, 0 point there. And then from that point, we'll go up to, over 1, up to, over 1, or down 2, back 1, down 2, back 1. Stay on the same line. And there we go. Okay? And we're going to come back and work that one very quickly in another way in just a moment. Let's go ahead and do the same thing with this one. Let's get it in slope-intercept form. So we've already got a 2y. We want to get rid of the 5x because our slope-intercept form just has y on the left. So we subtract a 5x from both sides. And this is going to go away. Just cancels. 2y is negative 5x plus 6. Now, I put the x term first because remember my slope-intercept form of the line is y is mx plus b. So slope term goes first. And the slope, the term that has the slope is the x term. So now all I have to do to get this in slope-intercept form is get rid of that 2. Since it's joined with multiplication, we will divide by 2 and divide by 2 and divide by 2 all the way across. And I wind up with y is negative 5 halves x plus 6 divided by 2 is 3. Okay, so that winds up being my slope-intercept form of the line. And I'm going to make just a teeny little graph over here. We have a y-intercept of 3, so I'm going to go up 1, 2, 3, put a little dot there, and it is a negative slope. So down 5, right 3. So here we go down 5, 1, 2, 3, 4, 5, and right 3, 1, 2, 3. So it is a negative slope. Let's see if I can graph this halfway decently. And there would be a graph of the line. Now I'm going to leave those. I'm not going to erase that board because I'm going to do the same 2 problems another way. This is just a little shortcut, a nice way to find the slope-intercept form of the line when you are given the standard form of the line. So what I'm going to do is I'm going to give you a little bit of the theory here first. Okay. ax plus by equals c is your standard form of the line. Okay, and it is different from the slope-intercept form of the line. In order to figure out your slope-intercept form of the line, or the slope and the y-intercept, you're going to either have to put it into, change your equation around, just like we just finished these two, putting them into slope-intercept form, or you can use this little time-saving trick. Now what I'm going to do is I'm going to turn the generic equation around. That's an awfully big C, isn't it? Okay, so we're going to turn the generic equation around to turn it into slope-intercept form. So we want to get just the y term by itself. So we will subtract the ax term. This is the same procedure I've just done twice, but now I'm doing it with the generic form of the equation instead of with specific numbers in it. So now my ax and my negative ax will cancel, and I will get by is equal to, I'm going to move my ax in the front, so negative ax plus c. Almost there. So now we have to divide everything by b because we just want a y over here. So we divide by b, and of course we have to do it to the other side too. So y is negative a over b x plus c over b. And now we have achieved the slope-intercept form of the line. Remember, that's y is mx plus little b. Little b stands for the y-intercept. So doesn't it stand to reason that the slope, since I've got my y and I've got my x and I've got my constant term here, that the slope of the line is the negative a over the b from the standard form, okay? And the y-intercept is always going to be equal to the c over b from the standard form. So let's see how that works. Okay, I'm going to come over here and do the same two problems I did before here. So we're going to start with 2x minus y equals 0. 2x minus y equals 0. Okay, so instead of turning it around, which is not really hard with this one, but instead of turning it around, we're going to recall that our a is 2 and our b here is negative 1 and our c here is 0. ax plus by is 0. Okay, so if I'm going to use this little formula, my slope is negative a over b. Well, my slope is negative a, which a was 2, so negative a would be negative 2 over b. Since there's nothing in front of the y, except for a minus sign, it's a negative 1. So negative 1, and negative 2 over negative 1 is 2. And my y-intercept is c over b, but since c is 0, my y-intercept is 0. Okay, now we were graphing using the slope and the y-intercept. Remember, okay, we had turned this one around and the slope was 2 and the y-intercept was 0, and we graphed it this way. Okay, so if you know this little handy dandy switcheroo from standard form to slope-intercept form, you can usually very quickly eyeball a problem and figure out what its slope is without having to do a lot of work. Okay, the other equation that I was going to work for you is 5x plus 2y equals 6. So I'm going to do that one right here. 5x plus 2y equals 6. All right, so on this one, our a is the 5. Our b is the 2 that joins the y, and our c is the 6. ax plus by equals c. All right, but from what we did before, m is always going to be negative a over b. So our m, or our slope, is going to be negative 5 over 2. And our y-intercept, our little b, it always stands for y-intercept, is c over b. Well, c is 6 over b is 2, so 6 over 2 is 3. All right, well now go back to when we worked it out in detail, and we turned it around to y is negative 5/2 x plus 3. So negative 5/2 is our slope. And look what we got for our slope when we just used negative a over b. We got the same thing, a little bit faster. Okay, and then we got 3 for our y-intercept, and over here we got 3 for our y-intercept. So that's just a little shortcut based on some very sound math here. It's a shortcut you can choose to use or not. I just wanted you to have it available. Okay, so you're going to get the same results whether you use the little shortcut or not. And so this is the end of 4.2's little problem section, and this is Mrs. A, and may God bless your day.